So here, so NumPy, Pandas as usual, Cbol, Matplotlib, and still I have not shown you. I think yes, here we can. I will talk about this. So Matplotlib and inline is percentage Matplotlib inline. So if I have this, so yes, you can see this plt.show, right? So this will basically help us to plot this graph in the right size within the Jupyter notebook. All right. So if you don't want to write this, that is absolutely fine. It is not going to impact. So if wherever you see this kind of a line, so there most of the time we use plt.show. It's not that great or very important, but you might come across these lines in any code or somewhere. So that time you just assume that. So this is basically to show this plot, right? Without this also we can plot the graph. It's not a problem, but this is related to this plt.show. All right. So here I am going to use this pandas.plotting. As I said, pandas do have a plotting techniques. So from pandas.plotting, I'm importing a scatter matrix. Scatter underscore matrix. All right, scatter matrix. So let's import it. And here what I'm trying to do, I'm loading the iris data set. I don't want a species column. I'm dropping it and printing a head method. Okay. Let's run it. Now I'm using scatter matrix, which I imported from pandas.plotting. Import, have imported this and I'm using here, this is a data frame, comma. So this is the size of the graph. I need a 10,8, you can change it. So I will talk about a diagonal KDE and color, you already know it, right? So I will explain this. So then I will say show the graph, plt matplotlib.show. Let's execute this. Now we'll interpret this. So first of all, we'll talk about this diagonal KDE. So this is a diagonal. Whatever the graph it is going to show, it should be in the KDE. What is KDE? It's a kernel density estimation. So we don't care the name, but how it looks like this kind of a line, right? So this kind of a line, this kind of a graph. So why it is a diagonal, why it is not somewhere here, we'll try to understand. So KDE is kernel density estimation. So that's, it is looking like this. What if I don't give a kernel density estimation? Let me remove that. Now execute. It's a bar plot, sorry, a histogram, right? Hist. So it is looking like this. Why it is looking like this, we'll talk, right? So this is the KDE. So now what is scatter matrix, right? So what happened here, we know matrix in the NumPy and all, we discussed about a matrix. So columns, rows, right? The same thing in this scatter matrix. Scatter is one of the kind, we'll talk more about that. The scatter matrix, data is scattered, right? You see here, data is scattered. And what the matrix is, here I'm trying to compare one column versus another column. How many columns we have? We have sepal length, sepal width, petal length, and petal width. On x-axis, we have 4 columns. On y-axis also, I have the same 4 columns. Same 4 columns. And now, here I'm comparing sepal, plotting basically the data points. Sepal length data and petal length, petal width. This is the data scattered this way. So sepal length versus petal length. This is how both the data scatter, right? So sepal length versus sepal width. This is how they scattered. So here sepal length, I will take a different color here. Sepal length and sepal length. It basically what I'm trying to do. I'm taking the same column, trying to plot data from one column versus the same column, right? So in that case, this always comes at the diagonal, right? We know that in the academics and all. So if you are comparing one column versus the same column, so this is how the data is looking. Similarly, I can compare one column versus any other column. Any other column. You take any permutation and combinations, you will get the matrix, scattered data, scattered matrix. Any you can compare, however, petal length versus petal width. Yes, this is the data, right? Petal length versus sepal width. Yes, this is the data. So that's how you can interpret this. As of now, this is not making much sense, and don't worry about that. Whether it is making sense or not, we are not concerned about that. So that one we will deal in a different charts, different plots with some real examples. So this time we are trying to understand what is scatter matrix. I can take any data set and plot the scatter matrix where it will compare one column versus any other column. All right. So that is basically what the scatter matrix.